Right then, start the meeting. My name's Sean Greenwood, I'm chairman of the onshore panel of the Pipeline Industries Guild. This summer, Nigel with Victaulic won the Utilities Innovation Award, and he's going to be talking to us today about the product they've got. Over to you.
Thanks, Sean. Yeah, just a quick thanks to Sean and the Guild for allowing us to set this up to arrange this. Quite unexpected to win the award, so it was really good for Victaulic. As you can see, some of the information we'll be sharing today, a lot of it is outside of the UK, where we're having a lot of success with the settlement joint in the States, etc. So I put a few examples down there, but obviously due to 30 minutes, we'll keep it short and sweet. Any further technical information, I'll keep my contact details on the end slide, and then you can reach out to me as and when. Okay, we'll kick this off. So today's objectives, what we're going to discuss today is the history of Victaulic and the anatomy of a groove technology. If any of you ladies and gentlemen are aware of this, we're going to compare some groove technology with traditional methods, what you'll see as defaults in the marketplace nowadays. I'm going to
Apologies,
give you
Nigel. Hello, just
Hello?
1 second. I can't see anything. I don't know if you've turned the screen sharing off.
okay.
Will be 2 seconds. Let me know when you can see it again. Can you see that?
No, not yet.
It's loading.
Okay,
Yeah,
now.
you can see it now.
We got it. Yeah, great.
Right.
Okay.
We might just leave it on the minute screen like that. I think it's switching the Skype off when we go, but back to you, Nigel.
Yeah. Right, start again, guys. Yeah. Today's discussion points, bearing in mind we've got 30 minutes today, is just a brief history of Victaulic, the anatomy of a groove, coupling technology, etc. What goes with this. We're going to compare some groove technology with everyday traditional welded and flanged and mechanical jointing methods that you see nowadays in the market. I'm going to give you a little overview of a job we did in Toronto, Canada. The Hanlan main feeder made 96-inch pipework coming in to the city of Toronto, and how we gave a solution to the project when phase one wasn't going too well with traditional methods. Then we're going to discuss a UK project that I got involved with last year, large diameter one. Then we're going to obviously discuss a W257, which is what we received the award for this year from the Guild. And if we got time, any questions? But like I said, the end slide will be with all my contact details on, and then obviously if you lose that, Sean's got my details anyway. So we'll kick off. Right, just a quick timeline. The groove concept was originated in World War I for the deployment of water and fuel lines to the Allied forces, dismantling and installation of pipelines across fields. They wanted a quick, easy method. So we took that concept and we took that deployment back in 1919, and we painted it as Victaulic, the groove concept. Then later down the lines, 1922, 1925, we created the word Victaulic from victory, from the Allied forces and hydraulics, from a pipeline design point of view. And in 1925, we subsequently founded the Victaulic Company of America. Victaulic now has expanded. We're 100 years old this year, with 15 major manufacturing facilities and 28 branches worldwide. We've got 5,000 employees who speak multi-languages across the globe. An important thing with Victaulic, our systems, we manufacture every component. So all the coupling housings, the valves, the rubber technology, the gasket technology, it's all manufactured from cradle to grave with ourselves. So that makes us a global leader in mechanical pipe joining systems. Just an example there of old technology back in 1927. We're still finding now when the Thames water is being developed now, we're still finding lines in service that have the groove technology, the Victaulic groove technology being utilised. We're taking the couplings apart and the gaskets are still fine. In some instances, the gaskets are slightly disgraded, so we've replaced them, but the housings are fine and not being really replaced. It's just the gaskets, etc. So the technology and installation goes back many years. It's still being used nowadays. Obviously, we've grown the technology, the innovation we've now brought to the markets is quite substantial. Right, I'm going to talk about differential settlement today and dynamic movement. We've all seen this within major pipelines through our long and short careers in pipelines. On your left hand side there, you've got a traditional tandem style couplings where you get a pair of a VJ style coupling. But to give them movement in service, you need to weld anchors and utilise tie rods to give the movement there. Still not fully restrained because it only offers 3/8 of an inch movement, and you still got to use thrust blocks where possible. But it's what you see in the market nowadays, along with the ball type joint there, which can be quite expensive on bridges, tunnels, etc. And then on the right hand side, you've got our flexible couplings and the W257, which is our bespoke settlement dynamic movement joint that we manufactured, designed, and brought to the market based on pairs of flexible couplings. A little bit about the, and I apologise if I'm teaching anyone how to suck eggs. It's what you see on the market nowadays. It's a dresser style coupling where tie rods are required. It'll only permit 3/8 movement. It can be buried, but obviously hydrostatic testing must be carried out prior to this, and good working practice says you've got to periodically tighten those bolts to ensure that it's still working okay. As previously said on the previous slide, it cannot resist thrust forces, so obviously needs thrust blocks, etc., and external restraints. And more importantly, when it comes to movement, dynamic movement, it cannot take shear or bending force. It's purely joining pipes together, but any excessive movement, it cannot handle that. Hence, it's not really rated for in-service movement. Again, you see the traditional methods out there, concerns when it comes to movement, differential settlement and other types of movement like expansion, etc. It can be quite cumbersome. There's a lot of weight in there, especially on this particular picture there. We'll go into this picture in more depth on the case study, but this was 96-inch pipe work. You can see two couplings there with the white tape, subsequently supported by the welded harnesses and the tie rods. So you've got a huge cost there. You've got an installation and maintenance challenges, because those tie bars there on this particular pipeline was 21 foot long. So you've got excavation to actually install these onto the actual harnesses. So there's no real testing involved to show movement and what you can expect from this type of coupling. Corrosion protection, yeah, it's always the case. If it's not being coated correctly, if the tie bars are of a material where it's not going to rust, you've certainly got challenges there, and periodically you're going to get leakage during service. So coming on to the groove concept, the coupling, 4 major components obviously. Up to 70 inch we can direct groove into pipework, steel pipes, ductile iron, stainless steel, and polyethylene. So we're putting a groove in the pipe, whether it's a cold form groove where we roll groove it, or we cut groove it if the pipework's lined or being lined, etc. The gasket is the most important feature of the coupling, because that's the sealing area. That's a workhorse. So as I mentioned earlier, we take the material and we mould and we produce all our gaskets, so we can tailor the gaskets to the application, etc. So you've got standard gaskets as high performance EHP, PDM or nitrile, or we've got a silicon or PTFE, etc. But nuts and bolts, as you can see on this one, up to 24 inch, there's only 2 nuts and bolts to our couplings, which makes the installation very quick, very simple, with no torque requirements unless you go 14 inch and above. And again, the nuts and bolts can be supplied in various hardware, materials, etc. As is the housing. Standard housing is ductile iron, but we can provide these in stainless steel, duplex, super duplex, etc. So it's a pressure responsive gasket, so the more pressure that's put through that actual pipeline makes the coupling work a lot harder. From that technology, we produced the AGS, which is the advanced groove system. So on the bottom picture, you can see there the standard coupling, the existing, which were all produced all those years ago, and the Victaulic AGS. Straight away, you can see on the actual groove profile, there's a leading chamfer there. That helps installation on site. Obviously, a bigger coupling eliminates multi-segment housings, so we can get a 2-piece housing up to 60 inch. So in effect, on a 60-inch coupling on site, and I'll show you some examples later, it's 4 nuts and bolts, as opposed to flanges, other mechanical joints where it's multiple nuts and bolts which need torquing and re-torquing. And it's a flexible coupling. So this flexible coupling offers not just thermal expansion and contraction, it offers seismic movement. We have a lot of success, certainly in countries where there's seismic issues, California, etc. We do a lot of pipelines above ground and below ground using flexible couplings. Vibration attenuation, this means obviously around certain pump houses, pumping stations, we can dampen the noise purely from the rubber gasket and the ductile iron housing. So we've got better acoustic qualities than a traditional rubber or metallic arched bellow. And then obviously differential settlement, which is what we're here to talk about a little bit today. When obviously ground's compacting, you're going from a fixed or a building to soft ground, elevated soils, etc. Where the flexible coupling can really come into its own and show its qualities. As you can see there on the AGS coupling too, we call it an A dimensions from the start of the pipework to the start of the groove. That's the ceiling area, so that's the A dimension. It's a lot wider than an existing or a typical original style coupling. That means it can take heavy end loads, shear bending moments, and it's got a greater surface area for the sealing the actual joint. Again, that just gives you an example. Because we manufacture every component, we can go into production if it's not a catalogue item. On this particular job, this was 96 inch. As you can see on the right hand side, we've manufactured that coupling purposely for this project. It's assembled in 6 segments, but on site it's assembled in 2 pieces, top and bottom. Against, you can look on your left hand side there, a 96 inch flange with multiple nuts and bolts, which obviously makes a site install quite challenging and a lot longer. So our flexible couplings are fully restrained to accommodate expected movement, and that means obviously we've gone over this slightly: expansion, contraction, differential settlement and seismic movement. So that really makes it a dynamic movement joint. There's no external harnesses, tie rods, thrust blocks required. The gasket sealing surface remains unchanged during pipe movement, even on shear and bending moments. It handles full end thrust load, which is good for when it's accommodating long spans of welded pipe work, and I've got an example in a future slide. And it relieves stress in the system. So our coupling really works in the pipeline to relieve any stress further down the actual pipeline, which you may encounter with flanges or traditional jointing methods. And that's just a coupling geometry. So when that's bending, or in moment, you can actually see the axis there. I'm not really putting the mathematics in today's presentation, but I'm quite happy to share with anyone if anyone wants me to come in or share the mathematics behind our flexible couplings and the movement and how we produce the calculations regarding the W257, more than happy to share them today. Obviously, we 30 minutes, we're a little bit constrained on time, so we aren't getting into that. It would be about an hour long, the presentation. So what we've took from this coupling geometry is that if we produce multiple pairs of couplings, we can accommodate a larger deflection or a larger settlement area, which we'll come into when we discuss the W257. So going on to the example of a project that we did, this was in Toronto again, like I says, this was a 96-inch pipeline going in from the ocean through multiple valve vaults and fixed structures. On your left hand side you've got on phase one what was proposed. Now the chief engineer on this, Mr. Chris Sundberg, he was 37 years with CH2M. He's now since joined Victaulic as on an advisory consultant role. So Chris was a PM on this, quite proud of his phase one and the design of the actual coupling with the tie rods, etc. But it became quite apparent during the installation that it wasn't as straightforward and the problems that this type of coupling entailed during the job. So it was unrestrained, even though with the harnesses and the tie rods, because you still need thrust blocks, etc. He was only getting about 3/8 of an inch movement from that big old dresser coupling there. The actual tie rods in itself, installing the tie rods was quite a challenge, because obviously you had to dig a trench out to actually feed tie rods through the welded harnesses. Slight issue with the tie rods also, because the engineers had to cut mouse holes out of the couplings to actually thread the tie rods through. So the owner wasn't too pleased, came to Chris with his concerns. There was two more phases of the project to go, and he suggested to Chris, take a look at Victaulic. We've used these type of couplings in the past. Take a look at them. So our solution was, on your right hand side, we got one pair of couplings, 96-inch AGS, 10 inches wide. We tested these to over 300 psi with a 3-in-1 safety factor. And we produced 2.17 million pounds of thrust at 300 psi. The installation time for these were 1.5 hours each coupling. The installation time for the traditional joint on your left hand side was several days, going into weeks, I'm led to believe. So the solution was, we put phases 2 and 3, we produced from 48-inch up to 96-inch AGS couplings at multiple valve vaults positions. So the valve vaults didn't have to be reinforced, they didn't have to be anchored at any point, because the coupling flexibility took up any bending, shear, thrust block moments that typically you would anchor, etc. So the robust design intended for in-service movement is all incorporated into the flexible couplings. We've got technical submittals for these, which gives you full end load figures, etc. So it was a fast fuel delivery between 1 and 2 hours each. Although we ship these with, because 96 inches quite large, we ship these in 6 segments. We actually install these on site into 2 coupling halves. So from an install point of view, it was very quick, very clean. We've got a QA system, whereas you can see on the actual picture there, you've got your bolt pads there, which are joined together. There's no gap in between there. You've got a visual verification. Once you've achieved full contact with the bolt pads and torqued it to the required torque setting, that's it. Basically, you don't have to go back and periodically tighten these or torque these nuts and bolts. It's just a one-off installation. So we can direct bury these, we can surface mount these, obviously for overground deflection. There's a self-restrain, we just mentioned it earlier, from the PA force. So we're not putting any external harnesses, thrust blocks, etc. into the design. 96 inch at 300 psi, which was a first, I'm led to believe, in large diameter water pipelines, and less expensive than traditional joints out there with the tie rods. So yeah, we gave the owner on phase 2 and phase 3 a great solution, and both phases went incredibly well, came in on time. Chris Sunberg was so impressed, he joined Victaulic, so yeah, it was a good all-round solution, and everybody was happy. As you can see there, this is a UK project where we utilise pairs of flexible couplings to first of all combat differential settlement above ground, and then from an end load shear bending moment, this was 2 river crossings, 35 metres in total, and we accommodated the end loads and the bending moments of the 30 metre welded spans across the river. Obviously, the client being an environmental, this was wastewater, didn't want any joints across the river, typically. So we accommodated not just on land, we accommodated off these little stanchions coming out of the river and on ground. So that again, that was quite a good project for Victaulic. As you can see there, there's 4 nuts and bolts per coupling. It was installed in 2 halves. Typical installation time per coupling was 40 to 45 minutes. So from this technology, utilising pairs of flexible couplings, we've produced the W257, which we call it a dynamic movement joint purely because of the fact that it's just not thermal expansion contraction. It also gives you deflection, it all gives you seismic rotational movement, and it just simplifies the accommodating of dynamic movement. So a lot of the waterways company clients we're talking to now, they readily admit they've got issues with differential settlement in different areas. This is our bespoke settlement joint. If we can't accommodate it by utilising pairs of flexible couplings, we've got this bespoke fitting that we can build basically to the client's designs. Now we've produced this and we've put this into the market, stating we can accommodate up to 4 inches of dynamic movement. But really, there's been some occasions, certainly in the United States, where we've accommodated up to 1 metre of settlement. Again, this is going to be a large unit when you accommodate 1 metre, because there's going to be more pairs of flexible couplings, but we've actually done this for clients elsewhere. So it's an engineered catalogue number, so it's basically built to order. It's in our catalogue. You've got a price in the catalogue up to 70 inch. Above that, it's obviously price on application. It accommodates settlement, seismic and thermal movement, and it's configured through pairs of flexible couplings. A little video here which just outlines what it is. So you've got a valve vault structure there, and this is how it's installed on site. So it's installed with 2 field couplings or adapters. It's going from a flange valve or a flange, an existing flange pipeline. We've got adapters to go to this. So you're installing it with basically 2 couplings. It's shipped already assembled. You can see the earth compacting around the actual structure. There's no real pressure on the structure because we're accommodating it throughout the W257. So periodically, over the course of time, when the earth moves, compacts, etc., you see settlement. On the back of that, as discussed, we've got submittals out in the marketplace too. So we've got a little micro website, which you can see there. Instead of going into the main Victaulic website, we've got one for dynamic movement joints, which highlights our flexible couplings and our 257. The submittal's in there, so it's a 20.16 submittal. A little bit more detail on the submittal. It's quite easy. Like I said, I've not really gone into the mathematics, the trigonometry of how we give you these figures, but I'm more than happy to. But obviously, it's with 30 minutes today on this Skype call, it doesn't give us much time. So there's an example where you see a pipeline. You've got a pipeline 14 inch, 350 millimeters. You go to the next one, pairs. That means pairs of couplings. Capability per inches per feet of the couplings. Pipe end separation, because you're always going to get that with Victaulic through expansion contraction. And then this is the settlement. So the actual pipe length in the middle of the couplings is determined by how many pairs of couplings you utilise. So the more couplings you utilise, the lesser length what we call a rocker pipe in the middle of the unit is going to be. So when we're talking to owners, engineers, etc., they basically know what sort of settlement they're looking for. They know the size of the pipeline, and we can give them options, and they know obviously how much room they've got to install this type of unit. So with 1 inches with settlement, if you go, for instance, 2 inches of settlement on this, 3 pairs of couplings, your pipe length, your rocker pipe length in the middle is 1.992 meters approximately. So where to use a W257? Above and buried applications, anywhere where pipeline exits the structure, including buildings, wells, valve vaults, ground penetrations, differential settlement, fault lines or seismic movement. Movement due to unstable surfaces. So if you're going from a soft to a hard surface, force-free soil heaving, bridges and tunnels. We've used these quite consistently overseas on bridges where the pipeline is deflected going over the bridge, and obviously earth movement. It accommodates that, as well as the deflection. It also accommodates the movement within the structure. Building movements and below to above ground transitions. Again, I've got lots of case studies for each one of these applications, so if anyone needs any more information after the Skype call, just reach out. Just a few examples of a 72-inch 2-pair and a 96-inch 2-pair. We've actually got a 122-inch pipeline going on at the moment in the States. I was hoping to have the install photos before the Skype call, but it's been delayed a couple of weeks. So in a couple of weeks' time, I show some really nice install photos. But going on from that, I've got some photographs here where you're going from two structures on an even ground. We've utilised 2 W257s on this occasion, as you can see, at the base and at the top of the building. So any ground movement you're going to get on any uneven surfaces, the W257 accommodating this. As you can see there from the picture, the site couplings are installed in two housings, not multiple housings. So again, that guy will be installing the W257 with 4 nuts and bolts per coupling, which again is very quick, very clean. And that's a nice overhead picture there. So they're utilising 2 W57s per line. Due to the uneven surfaces and the elevation going from one structure to the other. So I think these 80 total, so 16 W257s in total for this particular project. So basically, as an overall summary, just much more than couplings. So we increase the safety, from an install point of view. Maintaining schedule. We'll work with your engineering installation teams like we do on a lot of projects where we'll schedule deliveries, we'll come on site, we'll do the full training. We work from cradle to grave, so we like to get involved with the conceptual design. On the UK based photographs previously, we were involved on the conceptual design with those 2 bridge crossings. We can reallocate labour. That means obviously we're installing these, we're assembling these prior to delivery to site. Consistently, you're going to get consistency throughout all our flexible couplings, and that goes hand in hand with performance. And hopefully with the 257, we're giving you innovation now, where we're giving you a dynamic. I don't like to say differential settlement. I like to say dynamic movement, because it's all types of movement: axial, rotational, thermal expansion, contraction, and noise and vibration with the 257s. And the innovation is no external harnesses, no external thrust blocks. It's just assembled with 2 site couplings. And that's me done, ladies and gentlemen.
Thanks, Nigel. Really appreciate your time. Spot on half an hour as well, so perfect timing. How many people have got on the call at the moment? Any questions from anybody?
Not for me, no.
One from myself. How do we deal with ovality of the pipe when you're on two C-ring sections trying to piece them together?
Oh, right, that's a good question. What we have also, if we can go back to the UK project, this was a concept of the client too. Scroll back up there. So what we have, we talked about direct roll grooving and using what we call a Victaulic. Now on this particular project, again the client had issues, and these were questions posed to the actual installation team of ovality of large diameter pipework. So what we have, if you've not got a fabrication shop or you can't field groove or site groove, we have what we call an engineered Vic ring in effect. So it's a welded ring that we weld onto the end of the pipework. And it's got a pre-engineered roll groove within the ring. So that means you're not going to get any ovality issues. And the couplings, you don't need to do a site inspection on the depth of the groove. The couplings are just going to go straight onto that. So on this particular project, as you can see, these was installed with Vic rings. So the Vic rings was delivered to the fabricator. They fabricated the spools at their off-site fabrication unit, welding the Vic rings onto the pipe spools, sent away for coating, and then just assembled on site with couplings, which was, as discussed, 40 to 45 minutes each coupling.
Okay. Any other questions coming in?
Hi, it's Richard here. I just wondered, this is basically for coupling steel pipes, but is there any scope for using the system on ductile iron pipes?
Absolutely, yeah. We utilise this, especially overseas, a lot for ductile iron pipes. We've got systems for stainless steel, and that includes schedule, thin wall stainless, and duplex pipes, stainless pipes. And we do a polyethylene system, HDPE system now, up to 14-inch, 350 mm. It's a push fit mechanical joint, and above that, it's a groove in the system. And we've actually done some 55-inch HDPE as well. So all material types basically.
Okay. Thanks.
I know Sean's going to ask questions after the fact, so you've got my details anyway. So if you want to drop me a line, more than happy to come in and do a little bit more on the mathematics regarding the movement and how we come to those figures for accommodating settlement, a little bit more detail. But any lunch and learns, technical presentations, or you've got any, even better, if you've got any projects on your desk in the pipeline, excuse the pun, that we can look at that has settlement issues potentially, please get in touch.
Okay. Two last points. Nigel mentioned there might be some photographs coming of over 100-inch coupling coming in. Please put them up.
Absolutely.
We've got a big photographic competition going on, so
okay.
Get in on that one. It applies to anybody on the call if you've got any good pictures of pipelines. And then the last one, next presentation is Monday, 7th of October, which is Rosen talking about pipeline DNA and how to spot the different steels within a pipeline from a pig. Thanks for all your time, everybody.
Thank you.
Bye bye.
Thank you. Cheers, Sean.